Hey guys, welcome back. This will be the 7.4 instructional video. And what we're going to do here is we're going to apply our knowledge of 7.1 through 7.3 to some real world scenarios. Okay, we're not going to learn anything new in 7.4. Rather, we're going to apply our knowledge of using elimination and substitution for solving systems of equations to some real world scenarios. So let's look at this first one. To inform community members about what is happening in the school, Van Buren publishes a newsletter. It costs 90 cents to print and mail each copy, plus $600 total for gathering the information and writing it. Van Buren decides to sell each newsletter for $1.50 to cover the costs. How much must be sold for Van Buren to break even? Okay, so there's a lot going on here. Let's break this down into parts though. And I think it's always good to start with the question, okay? What are we asked to do? We need to know how many copies of the newsletters must be sold for Van Buren to break even. And maybe this term break even is new to us. So let's talk about what that means in a business sense. Well, if we think about a business, we'll have a little section off here to talk about what break even means. When we think about this in a business sense, every business starts out losing money, okay? You're like, what? That doesn't make sense. It's true. When we think about any business, we'll have dollars on the y-axis and number of items sold. Okay? Number of items sold. Every business is going to start out not making money. Okay, what do I mean by this? Well, when a business began, like our newsletter business here, there are always some upfront costs. If we look at this problem, we can see, hey, we're starting off with a $600 cost just to gather information, plus to make any newsletter, it's 90 cents to print it. Okay, 90 cents to print it. So we're already starting in the hole, even if we never sell a single copy, sheerly because of the $600 it takes to get it off the ground. So maybe for our costs, we can underline those in red, right? We're starting at $600 and then our costs are going to go up the more we print the newsletters, okay? If red is our costs. So why would anyone do this? Well, what we do to make money is we then sell things. We sell the newsletters. And specifically, you'll notice we're selling the newsletters at a higher price than what we are making them. Not so high of a price that people won't buy them, but selling them so that we can make a profit. And if we sell enough of them, because we are increasing at a greater rate, even though we start at $0 for how much money we're making, because we're selling them at a greater rate, eventually, if we sell enough of them, what's going to happen is our costs are going to be eclipsed by how much money we make. This green dot is known as the break-even point. So any business starts with the red line. If the red line we consider the costs, and the blue line we consider making money. Because of that $600 initial fee, it's going to start higher up on the money chart. And it's 90 cents per, so it's going to be an increasing line. But if we're selling them for more, our money making is going to increase at a steeper rate, but it starts at zero. So for a period of time, it's going to be below your cost. You're going to be in debt, but eventually, if your business does well, you will make the amount of money you make will eclipse or go past or increase beyond, go above your costs, and that will be your profit. Okay, so there's a little background. Here's the point. They want us to find that break-even point. I'll make the colors match. We need to find that green dot. And really what we can see here is these are going to be two linear equations. Okay, and we know that we can use graphing, elimination, substitution. We're going to focus on elimination and substitution here to find that point of intersection, to find that solution. Okay? So what makes sense to find how we're breaking even? Well, What are our two categories for our equations? Well, we're going to need an equation for the costs, and we're going to need an equation for making money. And when those two intersect, that will be the break-even point. That will be the break-even point. So how can we write two linear equations? Well, let's look at the information we're given. Let's start with cost. It costs us 90 cents to print and mail each copy, plus $600 for gathering the information and writing it. What I don't see, even though I typically look for it, what I don't see here is a total. I don't see anywhere that indicates Van Buren spent a grand total of blank creating the newspaper. I see how much each part costs, but I don't have a total. Okay, I don't have a total amount of money spent. So we'll use T for total money. We'll use T for total money. And what is making up that total money? Well, we have a $600 upfront fee, but that is not going to get a variable because it's not based on a number of newsletters or it's not changing. It's just $600 upfront. No matter how many I sell, I have to pay $600. What will have a variable attached to it is the 0.90 because that cost, that part of the cost is going to be dependent on N, the number of newsletters we sell, or the number of newsletters we produce. Really, just the number of newsletters. Okay? Because the more newsletters I make, the more my costs are going to increase because of, again, the printing and mailing and all that good stuff. So our costs can be resembled by the equation T equals 600 plus 0.90 times N. A little bit weird because usually we have an amount for the total, but in this case, we don't. So we use the variable T for your total, okay, the total amount of money. And we're looking at the costs. What's making up that total? Well, it's your $600 initial cost plus 90 cents per newsletter. Let's now look at the making money equation. And again, I have no idea how much money Van Buren makes off this newsletter. There is no indication of it. So again, I'm not going to change the variable. I'm still going to use the variable T because I'm still talking about total money. Even though we're working in a different equation, I'm still looking at the total money in this case. And how is Van Buren making money? Well, I am given information about the parts. I don't know the total amount they make, but I am given information about the part. And they are making money by selling each newsletter for $1.50. And again, I'm going to attach via multiplication that variable N because that 150 will be multiplied by the number of newsletters we sell, N being the number of newsletters. So while a little bit different because usually I have totals I can identify, I didn't have totals in this case, but we still came up with two linear equations representing the costs and making money. And again, from our knowledge of breaking even, we know that break-even point is going to come when these two equations intersect. How do we figure out where they intersect through the solution to the two equations? This is where the elimination and the substitution come into play. Okay? I don't know what your favorite method is. For me, I think it depends on the case. I think substitution is probably a little bit easier here because we already have a variable by itself. So for T in the top equation, I'm going to plug in 150N, or 1.50N. And now I have a single variable equation that I know how to solve. So what I will do is I will take away 0.9N from both sides. Leaves me with 0.6N. Equals 600, divide by 0.6, divide by 0.6, and I get N equals 1,000. N equals 1,000. Now again, you need to be able to, and this is incredibly important, you need to be able to interpret your answer. So let's go back and look at what the question was asking us. We wanted to know how many newsletters needed to be sold for Van Buren to break even. Well, according to the work we've done, we can see that it will take Van Buren 1,000 newsletters to break even. 1,000 newsletters to break even. Now, how could we check this? How could we ensure that this is indeed correct? Well, breaking even implies what? That the amount of your costs and the amount of money you make are the exact same amount. So let's plug 1,000 in for n in both equations. If I plug it in the bottom equation, I find that the total amount of money made if I sell 1,000 newsletters, write it in a different color, is $1,500. And by plugging 1,000 into my first equation, I also find that if I sell 1,000 newsletters, or to make 1,000 newsletters, it's again going to cost me $1,500. So because those numbers are the same, we have found that break-even point. Our answer makes sense. So in order for Van Buren to break even on the newsletter, they would need to sell 1,000 copies. And this is things that businesses will do. Now, businesses will take it to the next level and they'll start digging into the analytics of, is that worth it, right? Do we think we can realistically sell over 1,000 copies and make some sort of reasonable profit? Because you also still have to account for the man hours that are being put into this. And that's where businesses would go from there, thinking through the logistics of it. But you have to start at a place of knowing where that break even is going to be. And again, Van Buren would ask themselves, can we logistically expect to sell 1,000 newsletters if we would decide to create one? Okay, so hopefully this makes sense, again, where the equations come from and all that. If you are confused, go ahead and email me. But otherwise, let's move on to our next one. You have exactly enough money to buy a loaf of bread at $1.95. You have 12 coins, all quarters and dimes. Write 2 equations modeling the situation and find out how many quarters and how many dimes you would use to pay for it. Now, in this example, I am going to write out the 2 equations, but if you believe you have a better way of solving it, of just thinking it through and meeting both criteria, be my guest, go for it. So looking at this problem, how are we going to set this up? Well, we have exactly enough money to buy a loaf of bread at $1.95, which means we ourselves have, if we're thinking about money, we have $1.95. And in order to make, we have exactly that amount, and from that amount we have, or to reach that amount, we have 12 coins. Okay, so we're walking in a store, we've got that $1.95 in the nose, but it's in coins in our pocket. Specifically, it is 12 coins. So that indicates to me we're talking about a different topic. Now we're talking about number of coins. So I'm going to write a separate equation for that. Now, unlike the previous problem where I was given parts, but I didn't know the totals, so I had to set some variables, here I know the totals, but I don't know the parts. I know I have $1.95, but I don't know quite what's making it up. I have 12 coins, but I don't know how many of each coin. Okay, so we're going to have to figure that out together. So let's think about the 195. We have 12 coins. All of them are quarters and dimes. So how can we think about this in terms of money? Well, a quarter is worth 25 cents. So some of this 195 is going to be made up of 25-cent quarters, and the rest of it will be made up of by 10-cent dimes. And we don't know how many quarters I have or how many dimes I have, so I need to set a variable. Q being the number of quarters, D being the number of dimes. So I'll label that up here. Q is the number of quarters. D is the number of dimes. Okay? But I can't just stop there and ignore the 12 and solve that equation. A, because I don't know how to physically isolate a variable in a way where I'd get Q equals a number and D equals a number when we have 2 variables. But also I have 12 coins. That is another criteria I have to meet. I have exactly enough money, which means I have $1.95 in my pocket, but it's made up of 12 coins. Okay? So let's think. I have 12 coins in my pocket. Let's think about the coins a little bit more. What are those coins? Well, we know those coins are quarters and dimes. Okay? Specifically, there's some number of quarters and some number of dimes in my pocket, which we already set variables for. So what is making up this 12 coins? Well, some number of quarters, some number of dimes, which we have used the variables Q and D to represent. And now I'm in a place where I have equations that I know how to solve. Okay? When I look at this, there are a couple different ways I could solve this. Could I use substitution? Yes, it's not terribly difficult to get the letters Q or the letter D by itself. You would just have to do some subtraction if you wanted to do substitution. But I think here we'll go ahead and try some elimination. Now I need to get a variable to line up, so I will multiply both equations by 0.1. Go ahead and rewrite them. So 195 equals 0.25Q plus 0.10D. 12 times 0.1 is 1.2. And then we have 0.1Q plus 0.1D. What I can do now to eliminate my letter or my D variable, I will go ahead and subtract. And that leaves me with 0.75 equals 0.15Q. Divide both sides by 0.15. And I find that Q equals 5. And once we have Q equals 5, we can jump back up and quickly figure out what D is, because if we have 12 equals Q plus D and we know Q is 5, and by a little bit of algebra or some mental math, we can quickly find that D equals 7. And again, let's think about our answer and make sure it makes sense. Okay, we know that 5 quarters and 12, or 5 quarters and 7 dimes does meet the 12 coin criteria. Well, let's triple check by plugging 5 and 7 into our first equation, the $1.95 equation, to make sure that 5 quarters and 7 dimes does indeed add up to be $1.95, and in fact it does. In fact it does. Okay, so we can see here again by setting up some equations using elimination, we can find out how many quarters and how many dimes we have. Okay, if you would like to just think this through, if the equations aren't quite for you, that's okay. Just make sure you don't forget about both criteria, right? Don't come up to me and say, hey, 7 quarters and 2 dimes will work, because while that meets the $1.95 criteria, it may not meet, or it will not meet the 12 coin criteria. So make sure you hit both. Let's look at one more example. You are at a cafe in Paris with a friend. A local in front of you buys a cup of coffee and a croissant for €5.30. When you and your friend get 2 cups of coffee and 2 croissants, you are charged €14. Set up a system of equations, solve it, and explain what your solution means. So let's look at what's going on here. We are purchasing things at a cafe for us, me and my friend, 2 cups of coffee and 2 croissants. So maybe we can use X and Y here. Say X is coffee, specifically the cost of the cup of coffee. We could say y is the cost of a croissant. Notice it's not the number of croissants and the number of cups of coffee, because that's already illustrated in the coefficients, the 2 and the 2. And we paid 14 euro for those. 14 euro for those. But the local in front of us also bought a cup of coffee and a croissant, which we've already said the cost for those are X and Y. And their total was $5, or I keep saying that, 530 euro. Okay? So 2 cups of coffee, 2 croissants, 14 euro, 1 cup of coffee, 1 croissant, 530 euro. Okay? So we want to set up a system of equations, which we have done. Now let's go ahead and solve it. And while we're solving it, let's think about what this means. Use your variables to inform you what we're trying to look for. In this case, we know how much product was purchased, but we don't know the cost of the product, right? We do not know the cost of a cup of coffee, and we do not know the cost of a croissant. But theoretically, if the prices are consistent, by solving this system, we should be able to figure out, here's the price of a cup of coffee, here is the cost of a croissant. Okay? So we go ahead and solve this. Elimination probably would be the best method. So we multiply the bottom equation by 2. Rewrite my equations. And we go, okay, now my variables line up, but it's almost too good in the sense of lining up variables. Usually we only line up one, but in this case, both our x's and our y's have lined up. So that when I subtract, I get a really weird situation. When I go ahead and subtract, both my y's and my x's cancel, so my entire left side turns out to be 0, and my right side turns out to be 340. Now this doesn't quite make sense. Our math is good, but we ended up with an untrue math statement, which we know means there is no solution to the system of equations. There's no solution. So let's take a minute and let's think about what that means. We're at this cafe and we paid 14 euro for 2 cups of coffee and for 2 croissants. The local bought a cup of coffee and a croissant and paid 530. Well, if we imagine a world, maybe we did get a solution, and I think it's helpful to think about it like this. Let's say we got the solution 2-1. What would that mean? Well, if we got 2-1, or we got x equals 2, and we plugged it back in and got y equals 1, that would tell us that, okay, the cost of the cup of coffee is $2, and the croissant is $1. And in that pricing, if by that pricing, both equations would be true. It would make sense that that was the cost for the local and for us. Made both of our situations true. But when we run into no solution, what does that mean? Well, that means there is no x or y value that makes both equations true. In other words, they're using our interpretation of our variables. There is no price point for the cost of a cup of coffee and the cost of a croissant that can make both of these statements true. It means something fishy went on here. The pricing is inconsistent. You see, the pricing should be consistent. We should end up with some x value and some y value that says, here's the cost of the cup of coffee, here's the cost of the croissant. It makes both bills make sense. But there is no cost for the cup of coffee and croissant that can make both bills true, which means someone got ripped off. And based on these total prices, it looks like we got ripped off. And by looking back at the equations, this should make sense. Pretty much our bill was just double of the other person's. We just got 2 of everything they did. So if we got 2 of everything they did, then our cost should have been twice that of theirs. But ours is almost triple. It looks like they might have ripped off the torus. So hopefully what you see here and what you get is that we can use our knowledge of elimination and substitution to solve systems of equations, which in turn helps us solve real world problems. The big skills I want you to be able to take away is not just what is your solution, but as you've seen in the last one, it can be very important to interpret what your solution means. So make sure as you solve the homework, you label well, you are very specific with your variables, and you can interpret what your solution means. If you are still struggling with this, as always, shoot me an email. Thanks.